Hi guys, today I will be happy to discuss about project management, process management in Linux. So a process is a program which is in the middle of execution. Just more than a code section because it contains all the setup resources such as memory address space, kernel data, open files, signals, data section, etc. So it can be like having a combination of multiple threads of execution. Threads of execution are like or simply threads are like objects of activity within a process. So each thread has a unique program counter, process tag, and set of process registers. But some of the other things like this signals etc. are shared between different threads within a process. So this kernel schedules the individual threads. So fork is the method, the system call, which creates a process by duplicating the existing process. So the parent resumes execution and child starts execution at the same place where the fork returns. Fork returns in Linux kernel twice, once in parent and other in child. So this process descript this exec is the command which is used to create a new address space and load a new program to the address space. That means after immediately calling fork, if you call exec, a new program will be loaded into the address space and it will start executing from that place. And process is executed by exec system call. So the process is described in Linux as like it's stored in Linux like a process descriptor. There's a array like a list of process descriptor. It is stored in double linked list called task list. So each element in task list is a process descriptor of type task struct. So process descriptor is dynamically created via slab allocator. So a new structure called a thread info is also created in case of for executing the process, and it lives in bottom of the stack or top of the stack depending on the stack structure how it is implemented. So this process descriptor has all the data the kernel needs regarding a process like open files, process address space, pending signals, process state, etc. So this is the thread infrastructure. You can see all the information related to a thread is stored in this structure. So it is even pointing to the which task it is belongs to in as the first element. You can see that in this structure. So Linux identifies processes by using PID or process identification value. So you can check this PID in slash proc slash kernel slash bitmax. So its maximum value is 32,768, but it can be high as 4 million. It can be modified actually. So this process state can be of different states. Process can be of different states like task running, task interruptible, task uninterruptible, task traced, and task stop. Task running is like the normal state of a process, which is like it is either running on a is either running or on a run queue, waiting for running. So this is the only possible state for a process executing in user space. It can also apply to a process which is currently running in kernel space. So task interruptible is a sleeping task waiting for some event to occur or some condition. So this is like if signal comes, the task will start running or something like that. So task uninterruptible is the same as task interruptible, but except that it cannot be interrupted by any signal or any condition. The task traced is actually the task which is traced by a debugger or something like that. So the for when we call when we send a signal stop, the task can be stopped. So the task will be in stopped state. So it cannot be run. It is not eligible to run. User space and kernel space. Normal program execution happens in user space. When a program executes a system call, an exception will be triggered, and the kernel executes on behalf of the process. All processes are descendant of the init process, whose speed is 1. Init is the last step of the booting process in case of Linux systems. Each process has exactly one parent and can have or cannot have a children. So copy on write is a another like improved technique because normally when we call a fork, all the resources are copied to the child. But this copy on write is like we is optimized way. That means to prevent the copy of data. That means if suppose if I am going to call exec in the next call, this entire data which is copied, I mean, duplicated, is waste. So we don't want to do that. So this copy on write is like only when the child tries to write to some shared resource of the parent, that time only that resource is getting copied. Otherwise, if we are reading case and all, the parent and child will be sharing the same resource. So only overhead is the duplication of the parent's page table and also the creation of the unique process descriptor for the child. This is the new technique which is used in Linux nowadays. So Linux implements fork through clone system call. vfork is another system call which enables the child to execute in parent's address space, and the parent is blocked until the child exits. A thread is merely a process which share the shared resources like when compared with the other processes. So the next thread treats the thread as a process only. So for creating a process thread, we have to pass that clone VM, clone FS, clone files, clone signal handler to the clone system call. So the list of processes for executing the kernel's background processes is called kernel threads. That means in background, kernel has to execute many things. So these things are executed by kernel threads. They do not have a specific address space. They execute in kernel space. So ps minus ef can give you the list of the kernel threads. So when a process is terminated, it enters into a zombie state in which the thread infrastructure and task structure is retained in the kernel stack. So when the parent is like waiting for the using wait system call for the information of the terminated child, until and unless the information of terminated child is received by the parent, these things are retained in the kernel stack. So once the information about the child is received in the parent, this thread infrastructure and task struct are also deallocated. Parentless task is a very big problem. So in order to avoid that problem, if the parent is killed before the child is reparented to another task in the same group or to the init process. If the reparenting fails to the same group, it will reparent it to the init process. So that's it for this session, guys. Thank you.